at the end of the presentation. You can ask questions anytime during the presentation using the question box on the right side of your screen, and at the end of their discussion, Ron and Ludo will read the questions and answer them. And with that, I will turn the presentation over to our speakers.
Well, hello and thanks for joining our webcast. This is Ron Moore, and I'm joined by Ludovic de Paz.
Yeah, hi, good afternoon, Ludovic.
So a little bit about the two of us. We're both with Top-Down Consulting, of course, and I've been doing Essbase for over 20 years at this point, and have done many webcasts and Kscope presentations.
So I don't have as much experience as Ron. I'm trying to catch up, but not sure I will be able one day. I work with planning and Essbase, and presented on topics such as Calc Manager or ASO calculations in the past.
So one of the things that I like to talk about is how we can increase ROI. Many of us have very productive Essbase and planning implementations, and we're getting a lot out of it, but we can always get more. And I think that Essbase is vastly underutilized, and I think that's primarily because we don't take advantage of Essbase's greatest strength, which is its calculation engine. And there is so much new stuff in the last handful of releases, and that new stuff really applies to some very high value enhancements that we can make. So what are some of those things? How can we do better? Of course, we always want to make it faster, and of course the biggest thing slowing down Essbase is the aggregation, and we'll talk, probably most of what we'll talk about today is about how to make those aggregations faster. Make it easier, make the calc scripts right, syntax that we can understand better, less lines of code, and we'll see some of that. Probably most important is get better insight from our models. And when we talk about things like rolling forecasts, this is a great way to actually improve the quality and the power of the numbers that we're getting out of Essbase. So when we talk about improving the power and the quality, what are some of the initiatives or new features that we might want to try to address? Driver-based budgeting is always one of the things that I harp on. It takes less time, less work for the end users. It's actually easier to develop if you start with a driver-based budgeting design. It's one of the things that everybody talks about, but relatively few people do. A lot more people are doing it now. Rolling forecasts, and rolling forecasts is one of the things that the new features are really starting to make a lot easier. So we'll talk a lot about rolling forecasts in a few minutes. Better forecasts. Well, I think that driver-based budgeting and rolling forecasts both contribute to better forecasts, better because they're easier for end users and because they give more insightful information back. Better allocations. Allocations is another one of those things that it's pretty easy to get wrong. Better variance analysis. One of the things that I asked about at Kscope is, are people doing VPM type analysis, volume price mix type analysis to explain your variances in economic terms. And there's a million other things that we can use to improve our ROI. And one of the takeaways from this webcast that we hope you'll take away is that there are some big things, high ROI things that you can do, and they're not that hard to implement, particularly with some of these new features. When we talk about new features, these features are actually going back a handful of versions, but they tend to combine over the course of the versions from 11.123 up to 11.124, because many of the new features were introduced early on and then got big enhancements in the next couple of features. So here are the things we're going to focus on. Hybrid was introduced in 11.123.500, but got big extensions in 11.124. Fixed parallel was introduced in .500. In 11.123, we also got big improvements in XREF performance. We got runtime substitution variables, and we also got the X-range list and rel X-range, which are two of the most important features that we'll talk about in this webcast. So we'll focus on these four. Create block. Block creation is one of the problems we love to hate in Essbase, and create block just gives us one new option for dealing with a block creation problem. We'll kind of contrast fixed parallel and hybrid in terms of trying to make your aggregations faster or make them go away altogether. And we'll talk about rolling forecasts, particularly with rel X-range and with X-range. I did a webcast back in January for ODTUG, and there's the URL. It's related to this. It goes deeper into the rolling forecast calculations and does some other but simpler benchmarks on fixed parallel.
Yeah, Ron, sorry to interrupt. Apparently, some people had issues seeing the screen. Might be some firewall issues. So I'm
going to just try resharing it.
Yes.
Can somebody chat in whether that made a difference for them?
Yes. Actually, now you want to check?
Yeah, I've been asking. I sent a chat to a couple of people, but I haven't heard. Let me see. Well, why don't you guys keep going, and then
it'd be useful to check to see if anyone sees the screen, so we can isolate individual users versus a system-wide problem.
Okay, so yeah, it sounds like it's good overall. I'll work with the one person. Keep going. Thanks, you guys.
Okay. So block creation problem, a thorny problem, and many different ways to address it. But at create block, as you can see down here, allows us to create blocks if we know where the blocks need to be created. So we can deliberately create them. We'll create all of them in that range that we specify, so we may create more blocks than necessary. But the big advantage to create block, many people use set create non-missing block on, and that's a well-known, terribly performing setting. Does the job, but it's really slow. You can see that in this case, create block did the same job in 0.1 seconds that create non-missing block did in 15 seconds. So this is a much better option than set create non-missing block. Let's talk about rolling forecast, X-range and X-range list. Of course, these are not new. They were introduced back in 11.123. But over the course of the next couple of releases, many additional functions were added. to the X-range construct. So what does an X-range list do? Well, it makes two dimensions, and of course usually that's going to be the year dimension and the periods dimension, into one logical dimension so that you can address it as if it's one dimension, which is huge. Makes things an awful lot easier so that we can create our rolling calcs much more easily. So here's a syntax and an example. So here's the X-range part of that. We're doing an average here, an average range. And so what we're doing is just taking our X range and putting two terms in it, the beginning of the range and the end of the range. And those are going to be cross members. So in this case, January 2013 to December 2017. And we can drop that into a range list that we previously would have been limited to a single dimension. We're going to add rel X range to that. The rel stands for relative, and we can put a moving window with a start offset and an end offset, and then the X range list in the format that we saw before. So this gives us true moving averages. Some interesting advantages to the rel X range construct. The offsets can be variables, or you can do expressions. And we'll see an example of that in a minute. The offsets can be members or cross members, and I tested two-dimensional cross members. Of course, a cross member is when we use a cross-dimensional operator. One caveat, the dimension or the member on the left side of an equal sign, they call that the anchor dimension, and that can't be passed into the range. Kind of like a fixed statement that we can't, anything we're fixing on, we can't calculate that in the commands that are within the fix. So this is a similar type of limitation. So here's some code. Hopefully you can read that. So the first is a simple moving average. So we're using an average range, and we've dropped a rel X range into the range list. And we're using a simple 3-month trailing moving average. So the minus 3 months to minus 1 month. Now, so that's how we're going to calculate our sales. In receipts, we want to convert AR days. Accounts receivable is usually discussed in terms of days, 45 days, 60 days accounts receivable. But we've got a weekly time range here, so we want to convert days to weeks. So we can't drop an expression, days over 7, into a prior function. So we could use a variable to calculate that days over 7. But we can actually do that directly if we come down here to receipts toward the bottom. We can do that directly within the rel X range. So that's going to be the minus AR days over 7, or AR weeks. And in this case, we want a single value for receipts. So we're summing a single value, which is, so we're using the same value in the start offset and the end offset. Now we do that because you can't use a rel X range directly. You have to drop it into a function, one of the functions that it works with. So we dropped it into a sum range, and we're only summing one number to come up with a single value for receipts. So let's take a look at a simple use of X range. Probably the simplest rolling forecast that people have done in the past is using an MD shift to go and get the December value for January of the next year. And that's easy enough once you learn MD shift and you stick it in an if statement and you put the if statement into a calc member block and you remember where your empty commas go. So, you know, moderate level of ease of use. You got to get used to it. But now let's look at what we can do with just dropping an X range into a prior. So with a simple prior construct, we can now do the same thing we did with an MD shift, and we can do it in one line instead of 5 lines. And not only that, but when we learn all this about MD shift, we can use it in exactly one place. We use that construct in exactly one place when we use MD shift. But we can use this X-range construct in a whole lot of places. Any of the places that the X-range list and X-range construct can be used, including things like the trend function, where we can do, that's our predictive analytics in Essbase. That's directly with the Essbase calc language as opposed to dropping predictive analytics into planning. And with the trend function, we can do exponential smoothing, and we can do single linear regression. So those are other examples of where we might use X-range, plus a whole range of the MOV functions and prior functions. So enough about rolling forecast. Let's talk about fixed parallel. So what does fixed parallel do? Well, it gives us additional control over the ability to parallelize our aggregations and other types of functions. So fixed parallel allows us to control the number of threads and the nature of the slices that we're parallelizing on. Whereas calc parallel allows us to do parallel calculations, but it always starts with the last sparse dimension. So fixed parallel can be used on any sparse dimensions as long as they're not in the command group. The command group being those commands within the fixed parallel block, just like a fixed command. So fixed parallel versus calc parallel. Fixed parallel allows us to control the tasks and the threads. Whoops. It allows us to choose the dimensions that we parallelize on. So now we don't have to think about changing the order of our dimensions. We can control that with fixed parallel. The common wisdom out there is that calc parallel is faster if it works, but calc parallel will be thrown into serial mode by many different types of calculations, and you can see an example of a few of them at the bottom. Temporary variables, xref, xwrite, and data export are some obvious ones quoted in the documentation. And if you look at the log file, you'll see the portion that's in the red box is an example of what you'll see when Essbase was unable to calculate in parallel mode because of these types of functions in use. And that's a good example of when to use calc parallel, or when to try calc parallel. So the calc parallel syntax looks as follows. We say in the calc script we set calc parallel and a number of threads. On 64-bit it's 1 to 28 threads. We can also increase the number of tasks by using set calc task dims and then give it a number of dimensions starting on the last dimension and working its way up. And so we'll look in our log file and we'll see a message about the number of empty tasks that we've got. And if we have many empty tasks, we may be able to rectify that by using set calc task dims to increase the number of tasks. So for example, if we had only 10 members on each of our last 2 dimensions, by default, using one task dimension, we might have 10 members over which Essbase could create tasks. But if we give it 2 task dimensions, it would be 100 slices over which Essbase could create tasks. So more of those tasks are likely to have be populated so that they would not be empty tasks. You have a finer gradation, so you can more likely find tasks that aren't empty. So a few guidelines. There's a lot of overhead in both fixed parallel and calc parallel. So it's easy to overdo it. It's easy to assign too many tasks and too many threads, and we'll see that in the benchmark. You can't use partition databases. For data export, we can only use text output, no binary or relational output. When we use data export, it'll write 1 file per thread, which can be bad if you forget that you've got multiple files and don't address importing them all. Or it can be good if that makes it easier to use parallel import and makes it that much faster to import as well. You can't control the order in which the tasks are completed, so that if you have dependent tasks, you may find that calc parallel is not a good choice. Doesn't support exclude and end exclude, and you may need to use an accumulation feature, because if your threads, for example, if you create your tasks across northwest, east and north, south, east, and west, and then you create the tasks across those, you may need to accumulate those 4 regions after you do the fixed parallel. So the recommended uses for fixed parallel tend to be these functions that force calc parallel into serial mode, and those are the ones that we've benchmarked. So here's an example. We're going to keep it simple. Here's the post-fixed parallel where we can use an accumulator. We did not benchmark that. Here's a simpler example that is an example of what we benchmarked. Here's a temporary variable example, and we benchmarked that as well. So you can see in these 2 cases, we're going to use 3 threads, and we're going to break the tasks up across our, in this case, scenarios. Here's a quick look at our benchmark database. It's sample basic with an all years dimension, and with dramatically expanding the markets and the product dimensions to over 1,000 members on each of the market and product dimension, and 11 years. We have a high cache of 200 calc cache of 200 megabytes, a default calc cache of 50 megabytes. Our product dimension is very dense. Our market dimension is very sparse in terms of population of the data. Here is a batch file that I wrote to loop through a whole range of tests. So up here we set a bunch of variables. We create log files that are named in a strategic way to break out the date and time of the tests, and the test variables, the value of the test variables. So we used, in this case, 1 and 2 task dimensions, default and high calculator cache, a number of threads from 1 through 10 without hitting every one of those. We have, in each case, 3 scripts will run: a fixed parallel script, a calc parallel script, and a regular fix script. And this will loop through those, passing those variables into our maxl script that we'll take a look at in a minute. And each one of those passes will write out its own log file that will be strategically labeled so that we can parse it out and understand what the values there mean. Then we'll go through with a find, and 101.2579 will collect the calc-elapsed times from all of those files and put them into a summary file. Here's a picture of the MaxL. I won't go through all the detail of that just in the interest of time, but it's here for those who want to dissect it. Here's an example of the Excel file that each of these is going to be a separate test run log file excerpt. We're going to break it up into the test variables. And if you look here at the top, you'll see some of the code I used to parse that out. Here's the an example of the three scripts. I've tried to keep them as identical as possible for comparative sake. I added a calc diagnostics, which creates a diagnostic file that looks like this. So it gives us a lot of detail about what's happening so that we can go back later and we say, oh, we've got some interesting results. Let's go back to the right log file and see a fairly complete picture of what happened in that run. So CalcDim, what we found here is that this is a pivot graph in Excel that brings in the, I used two different servers, a VM server and our development environment. These were all done on my VM. So we're going to analyze the task slice against calculator cache, default, and high, a number of task dims, one task dim and two task dims, and a number of threads indicated here. And we can see the green are the three best results. We can see that Calc Parallel delivered the best result, and a regular old fix delivered the second and third best result, with Fix Parallel the loser. And the reason why Calc Parallel or Fix Parallel would be the loser is because of the overhead of choosing the tasks overwhelms the benefit of dividing the tasks up. So we see here that a regular old fix statement does a pretty good job of choosing, of optimizing our aggregation. Moving on to data export, we get a very different result where Fix Parallel wins the first, second, and third place with some fairly dramatic results, as low as, in this case, two task dimensions with 2 threads, and high calculator cache being our winner with 56 seconds versus 72 and 71. Keep in mind that this is going to write, that's 2 threads, so it's going to write 2 files. Temporary variables, and here we see that a regular fix is the winner, and our orange Fix Parallel is overhead is a real killer here. Calc Parallel does almost as good a job as Fix Parallel. Here is our XREF test, and we see that Fix Parallel wins in the XREF test. So let's just take a quick step back and say, what did we do in the XREF? I pulled 3 members. These are identical outlines. I pulled 3 members from a source database, to a target database. And so fixed parallel gives us the best results in that case as well. So conclusions. Fixed does a pretty good job in most cases. Calc parallel is usually better than fixed parallel, but in both cases, overhead can hurt you, and fixed parallel can allow you to choose your threads and choose your task dimensions so that you don't have to reorganize your outline to take best advantage of parallelizing. Don't use calc parallel or fixed parallel by default. And again, don't use many task dims and many threads by default. So calc parallel and fixed parallel provide additional options to solve more thorny problems. So with that, I'm going to turn it over to Ludo, who is going to talk to us about his experience with a recent hybrid implementation.
Thank you, Mr. Moore. So what is hybrid aggregations, and what are we talking about? Can you go to the next slide, please? So, thank you. So a hybrid database is the best of both worlds, the best of BSO and ASO. What you have actually is like two layers. The base layers, which is all your level zeros, are BSO, and your upper levels are aggregated with an ASO engine. So to do that, next slide please. To achieve that, what you need to do, you need to change your Essbase config file so that your database, your application, is going to be a hybrid application. So you edit your Essbase config file and you add one line. Like the documentation is pretty good about it. But what I like to do is, at least for the moment, is to have all the, by default, have the applications not hybrid. And then I pick and choose and specify what applications I want to have as hybrid or not. So if you look at the example at the bottom of the presentation, by default, all applications are not hybrid, and then I created an application that I called Kscope app, and I make it hybrid. Next slide, please. So the other thing you need to do is that you need to make your upper members of the sparse dimensions dynamic calc. So, like in the BSO world, it's not the best practice. In the hybrid world, it's how you tell the Essbase engine that you want a specific dimension to be aggregated with the ASO engine. So what it allows you is that if I take one dimension, so here I got product, which is dynamic calc. If you look at it, market is dynamic calc as well. But if for whatever reason I just want product to be aggregated with the hybrid engine, then I make product dynamic calc and market stored. Then in this case, I will run an aggregation script, and it will perform an BSO aggregation. All right, next slide, Mister. Thank you. So I'm going to talk about two examples of hybrid implementation. The first one is we had an application that was working okay, but we decided to convert this application to hybrid to make it faster and then to make also this application better. The second case is to create a hybrid application to consolidate several applications. What we see sometimes is when in large organizations, you have like one application or one plant type by region, because your entity dimension is such that you don't need to have them in the same, you don't need to cross it across like applications. And then instead of having one big application, you have several smaller applications that are more manageable, and you have smaller database sizes. The thing is, with hybrid, you can have all these applications into one application, which will simplify your maintenance and avoid to have to move data between different applications. That also, like, it's more or less what you would do with an ASO database. So you have like different planning applications that then consolidate into one ASO database where you're going to do all your reporting. Then in this case, with a hybrid, you have everything into one application. So let's start with the example of a hybrid working with a good working application. Next slide, and again, next slide. All right, so what we have here is a GNA application, very simple application, 2 calculations, one for currency conversion and another one for aggregation. In this application, we have a lot of cost centers. The application is very sparse, very fragmented, and whenever you perform the currency conversion, whenever you perform the aggregation, everything takes time. So it's very simple, but it takes time, so the performance is not particularly good. Nobody really complained about the performance because it is like 5–10 minutes. It is still manageable, but we can do better. So next slide. It is so that's the application. So you see like a lot of years, organizations, like 6,000 members. It's not the end of the world. 500 entities is it's okay. So yeah, nothing special there. Next, when we converted this application to hybrid, then we have like a few things that are very, I would say, almost shocking. First of all, the number of existing blocks is ridiculous. Like 1,100 blocks, that's nothing. 0 upper level blocks. So here I took all the sparse dimensions and I made all the sparse dimensions dynamic calc. So they're all aggregated with the hybrid engine. And the other thing is that the clustering ratio stays very high. Explanation for that is that I think is that because the database is smaller, you're moving less blocks. So then you're keeping like a good clustering ratio. But also like the drawback is that because you have less blocks, if you make a change, if you're adding a lot of blocks or if you're making changes, then your ratio can drop a little bit faster. But in any case, like a database like that, you imagine the database size is like super small, and so the performance, even if you have a clustering ratio of 0.33, you will still have a good performance. All right, next slide. So, yeah, it took us approximately a week to do the conversion. Actually, what took us the longest time is not particularly working with the hybrid engine itself, but it's more like converting all the parent members from stored to dynamic calc. We are using EPMA, so like it's never easy with EPMA. But in the end, like the benefits were like huge, I would say. No need to run an aggregation. The currency conversion runs in 0.3 seconds. So then every time the user submits data, I run the calculation. and there is no need, like like in the task list, to have one task to enter data, one task to currency conversion, one task to aggregate. It's all in one. Like you only have like one form. You enter your data, you're done. So that's definitely a low-hanging fruit. So the next example, next slide, is the next example is how to use Hybrid to consolidate databases. So that's a little more complex. So in the example we have, like this example here is that we have like an application for retail where they have data by store. They have approximately 20,000 stores, more actually closer to 30,000 stores. They have multiple alternate rollups. So if I look at my store dimension, I have almost 70,000 stored members. So when I aggregate this dimension, it is really painful. The calculations are not particularly complex, mostly ratios, adding stores, removing stores, closing, then closing a store, doing renovations, applying same-store sales, so a percentage that you want to apply by country or by store, so at different levels, and calculating royalties. So the objective was several objectives. Number one, instead of having like, we wanted to have like a small databases, and we also wanted to reduce the number of databases and number of applications to have everything into one application. Next slide, please. All right. So whenever you start working with Hybrid, even with 11.124, you need to look at what is not supported. Because if you absolutely need some features, some calculations, you need either to find a workaround or maybe not apply Hybrid. So like I made a selection of the ones that I see and ones that I use and I see that are not supported. So add current member range, MD shift, which is quite useful, parents, xrange, that Ron just talked about, xf, xref, xwrite. Xref, xwrite, it makes sense because we are dealing with ASO databases and it's not supported.
Hey,
the
Ludo,
last one, yes.
Let me ask a question. When you say these things aren't supported, we're used to saying, oh, that's not supported, I can't use this at all. Is that what we're going to find with Hybrid, or are there some intermediate strategies that you could apply, yes, even if you have some of these functions?
So what will happen, and that's a very good point. So what will happen is that if you run one of these calculations, if you use one of these commands, the Hybrid aggregation engine will be disabled. That means that you're going to perform this aggregation with BSO. So if you think about the outline we had earlier, if you select, for example, let's say the top parents of the product dimension, if you select this member and you use the function xrange, it's not going to use the ASO aggregation engine, but it will use the BSO aggregation engine. So it will run a dynamic calc aggregation, because this dimension is a dynamic calc. It will run a dynamic calc to calculate the top parent member. So you will get a number, you will get a result, but it can take a very long time. Xref and xwrite, I tried it without knowing that it would not work, and I've never been able to even like move data. So it was just running and running and running for hours without ever writing anything. The other functions, if you look at the log will say Hybrid aggregation engine disabled because you are using the function add parent. And so it will run using like a BSO aggregation. So you can find workaround for all of these. Even Xref, you can always write an export script, and you will have a flat file, and then you load your flat file into your destination database. It works actually faster than Xref. MD shift, add shift, it's a little bit complicated to do it without. So then you need to be smart about it. The most painful one is actually not being able to use the cross-dim operator with a dynamic calc parent. So again, if you do cross-dim with level zeros, you'll be fine. If you have a dimension that is stored and you use cross-dim, you'll be fine. Now, if you use cross-dim on the dynamic calc parents, so then it will run a BSO aggregation, and it might take a little bit of time. But I'm going to explain how to work around this limitation with cross-dim. And on to the next slide. So my experience with hybrid is when you design your application, you need to keep in mind you're not designing a BSO application, but you're designing an ASO application. That will work better. So I suggest you avoid to pass calcs as much as you can. You avoid to have too many calculations that reference another member. That will not give you a good performance. The idea is really to keep everything as simple as possible. If you have a lot of dynamic calcs, what I recommend is to have not have these accounts as dynamic calc, but have them as stored. You have a calculation script or a business rule. You calculate everything level 0, and you let the aggregation engine make the aggregation. And very important is that make sure that you use a recent version of Essbase. Apply patches as much as you can. I read this morning that the latest patch available is Essbase 11. I know it works well with Essbase patch 7. The thing is you have some versions that have problems with large ESO retrieves, and that will hurt you when you go to hybrid. And I've not been particularly limited with hybrid. I like to keep everything as simple as I can. And so almost I was happy with hybrid, because if it gets too complicated, then the hybrid aggregation won't work. So I need to go back to the drawing board and make it simple again. Next slide, please. And also, you need to be smart about your formulas. So for example, I had this formula before. It says if add current member of period equals January, then you do this and this and that. Okay. So add current member is not supported by the hybrid aggregation. So problem there. And when you look at the script, you say, hey, why am I doing add current member? I don't need that. So then you make it more simple. If is member January, and then you do your calculation. And actually, it works as good. So never drop the ball. If you see something that disables the hybrid calculation engine, there's always a way to make it work another way. And actually, it will be more simple, and it will work better. And it will be easier for the person who's going to read the script after you, because it will be more simple. Next slide, please. Yeah, you can also use some calculations on sparse members. So I say don't use 2pass, but here you have an example with 2pass. It's not particularly complicated, and it works very well. I think as long as your database is not a monster, you'll be fine. What I noticed is I have a database today with 2 years of actuals, So my 30,000 stores, like all my accounts fully loaded, and I still have only one page file because it's only level 0. So it's still a small database. Yeah, next slide, please. Another example of scripts. So all dynamic calcs again, dynamic calc to pass. That was at the time of Kscope. Now I've made these, most of these accounts are stored. Like the percentages, I keep the percentages stored, but I found a way to remove the to pass. So I move these accounts to a certain point on the outline so that it's not to pass, and it calculates very well, but no problem with performance. Yeah, same thing with to pass, you know, it's to pass because it's located in a certain location on your database. So sometimes if you move your accounts from one location in your outline to another location in your outline, you can avoid to have to pass, so it will make it faster. But I have no problem with this type of calculations. Like the same as if you would have it in ASO database, it would work fine. So, yeah. Next slide. Thank you, sir. So the biggest issue is the biggest challenge with a hybrid database is clearly like the cross-DIM limitation. So you have like several options. One that I would call like mix and match. What you would do there is that if you know that you have a particular member in a sparse dimension that you need to reference in a cross-DIM, you can make this member stored instead of dynamic calc. So what you will have to do is to aggregate the database, and then this number will be calculated. I ran some tests, like the aggregation is the same as it would be like a regular PSO database, so it's not taking anything any longer. But you need to aggregate. And sometimes I find it can be a little bit confusing because you can have like one dimension which is like hybrid, one dimension which is not hybrid, or you can even have like some members that are dynamic calc, some members are not. Next slide, please. I'm all for consistency and simplicity. So I'd like to set like a ground rule, like all parents of all dimensions are dynamic calc. All calculations happen only at level 0. And if I do that, like if I have a stored member, what I would do is actually, let's say I need products, okay? I need to reference product in a cross-DIM. So because I keep the product dynamic calc, and I would create a member which is product underscore total. This one will be stored, and then I would calculate the member like total product total, and I say product total equals product. It will run the calculation the same as it would be like a regular aggregation, but I store my data as level 0. And I find it easier. And we're going to see an example just next slide. So if you need to cross-DIM a parent, you create a stored member level 0, okay? And you say level 0 member equal the value of the parents, which is exactly the same as performing an aggregation. Next slide, please. So I have an example here. So I have like a PLN country Canada, okay? That's a dynamic calc, that's the parent of all the stores that are in Canada. Now I created a member which is PLN CTRY Canada total, which is a level 0 stored member. I cannot use data copy because it's a dynamic calc. PLN CTRY Canada is a dynamic calc, so I cannot use data copy. I left it here because I wanted to tell you about, and you kind of forget that. But then I say PLN CTRY Canada total equals PLN CTRY CA. Actually, the performance to calculate this number for total is surprisingly good. And then I made it like almost like a best practice or something like that. And I've done that a lot of times. And because the database is small, the performance remains very good. The retrieve performance at the time of Kscope, like I looked at it, I looked at the logs, and I see when I retrieve like PLN country CA, if it's an hybrid, it will take a bit longer than if it's a fully stored BSO application. But we are still talking about sub-second retrieval. And also, when you're completely done with all your development, you can start to do some performance optimization. And now today, like the performance, like what you expect from an ASO database all the time. There's one thing regarding performance, is that with a hybrid database, you cannot force an aggregation the way you do it with an ASO. So because you cannot like create a view like the aggregated views, like you can read some performance issues if you have a lot of calculated numbers. Right, the big thing is that you cannot create a view, an aggregated view with hybrid. Next slide, please. So that said, you still have a lot of functions that work with hybrid. With 11.124, they added more than 100 additional functions, and some of them I use them all the time. Like add calc mode, I love it. Ancestors, some people use it, so I put it there. You can use attributes with 11.124 on hybrid. So again, what it means there is that if you have like if you have an upper member in the dynamic calc in a sparse dimension, you can use this type of calculation there, and it will work. It will use the hybrid aggregation engine. So you can use UDAs. Next slide, please. I use a lot of UDAs, a lot of attributes. Generation, at left members. You can use the date functions. You can use the account type. You cannot use. You can use at next, at prior. You cannot use MD shift, but you can do next and prior. At relative works. At relative X range works. Remove, I use it all the time. It works. And at var and var percentage. They work as well. Next slide. Wow. So another thing is that dynamic time series, they work with a hybrid. It's a big plus compared to ASO. If you have a very large hybrid application, you can have some performance issues. Then in this case, if you do like some numbers with a calculation, like say Jan is not good, but February YTD equals Jan plus Feb will work fine. I noticed some big performance difference, like because of the dimension order, like the same calculation went from 180 seconds to 1.2 seconds because that didn't have the correct dimension order, so just be careful with that. Next slide, and it's the last slide on hybrid. Actually, hybrid is just the beginning. The next versions of Essbase, we are really talking like the future, like 1 or 2 years ahead. Hybrid will be by default. They're going to remove all the limitations. You will be able to use cross-dim, maybe xref, xwrite, like exactly the way you do it with a BSO database today, with the performance of an ASO and without the limitations you have with a BSO in terms of size and performance. And also one thing they're going to add, I think later this year, is you'll be able to have like a solve order in BSO. And it will help a lot because like you need that when you do ASO. And I think that's it.
So thanks, Ludo. Let's see if we have any questions. If you have a question, you can chat it in. I do not see any yet. Okay, sounds like maybe no questions. So, and we're right at the top of the hour. So if there are no questions, then we can wrap it up. Thanks for joining us.
Thank you.
We'll see you at the next one.